not count.
Okay, strange.
It shows.
Oh, there it is. Share. Oh, application window.
In
Just
static, but
Anima, PowerPoint, slideshow, share. Okay. Now I think it should be right.
right, got it.
Okay. All right. Yep. Thank you very much for attending. So this is the Anima working group meeting. Standard disclaimer, right? Please mute your cell phones and all the other things about the IETF note well. I think we don't need to go through this in detail. Yep. I'm not sure if we have an explicit Jabber scribe. Anybody who's following would be lovely to help and basically reflect any possible questions from people who cannot get on the microphone line itself. I think Sheng will primarily take care of the microphone line as I'm sharing the slides. Joanna is going to take the minutes, and the other things should be well known. All right, let's get directly into it. So we have cluster C325 with all the documents in it not being blocked on anything but RFC editor. So that it means the Anima grasp, the prefix management, reference model, bootstrapping, and autonomy control plane. We're still getting updates on these two documents as they still had work since the last IETF. The cluster also has other documents in it, which, because by virtue of being linked to GRASP, but they're not really from our working group. So that's the main, round one of Anima Charter finishing up. So there's also the GRASP API. And that's going to be on the telechat in December. So it has enough positions to pass. So that would also go into the cluster. There was an update from the authors. I'm going to quickly show on the next slide, but otherwise no presentation here. Then we have the working group documents in their way into the working group. So there are the ASA guidelines from the individual draft 09. So that was adopted by the working group on mid this month. So I've assigned myself as the shepherd, and I haven't actually checked in the last few days if I think Brian had put in a version 00. Sorry, I didn't update that in the slide. So then we have the draft vendor stock. So Sheng was doing the adoption call for that. Please provide more feedback. I'm not sure what's the latest status of that Sheng.
We should already pass the adoption call because we don't have any, any objections on that. But I have to give a reminder for the author and other participants as well, because there are little discussing for this document for a while. I can fully understand that because this document already be around for a while, but as chair, we actually would like to see more discussing in the mailing list. Could please the authors submit the new working group document with zero version, but try to invoke more discussing in the mailing list. We need to see progress from now on. Thank you.
Yeah. And also, I guess that this stuff came from a particular IoT area. So one of the ways on how to get more feedback for these type of working group documents is also when we work with the authors and suggest presenting this, bringing this up on the actual, mailing list of the working groups that would use this stuff. Could even be ops area. I guess once we have the IoT ops working group, those things might be brought in there as well for further review and feedback from outside the core Anima protocol specification group. Okay, then we have BRSKI async enroll. We'll get an update in this meeting that was adopted after 107. And then we have the constraint voucher for which there is a design team formed after 108, also an update. We've got GRASP distribution. And since 108, there was some essential content merged from the GRASP bulk document. So the authors have been doing work, but we've been also running out of time, so there is no update given in this meeting, but check out the latest version. Okay, draft Anima GRASP API, given how that's going to be on its way out. So the list of changes here, so pretty significant good improvements from the review. I'm not going to read that out in more detail. If anybody has questions or so, please come to the mic and we can answer them here in this slot. I hope. Otherwise, let's move on. So non-working group documents, we've got the Anima voucher delegation that was updated after 108. So that's pending for adoption call. So we'll do that adoption call after this IETF meeting. We've got the only non-working group item that made it onto the agenda for this time. That's the BRSKI Cloud that's going to be discussed. And then there are 3 further documents that we discussed in 108 for which we haven't heard update. I guess it might be something like work overflow on behalf of the authors. So I'm assuming that, unless one of the authors may want to step forward and say something about them. Yeah, and any other interest or so, please come to the mic during this slot and note anything we've forgotten on the work side. So other business. So I mentioned the IoT Ops working group that actually was discussed, the first direction toward the charter just before in the Ops area meeting. I'm not sure if you attended that, so hopefully that's going to come down and it's going to be hopefully good adjacency for use cases, scenarios, and so on. No standards work planned with Anima. And I was making my concern that IoT is kind of a strange term, but I think routers and switches also have very much the same life cycle issues. So we should be inclusive of those devices as well, even if IoT people often don't think about them. I was giving a presentation about how GRASP should be great to do fairly pragmatic automation with ASAs in routing working group, which came up because there was this PEP protocol proposed, and so hopefully the PEP authors are going to consider focusing on the actual applications that they were suggesting, like automation of operational aspects of routing protocols, because those would be great ASAs to bring into Anima. That was the gist of it. Otherwise, please check out the slides about how to use GRASP for ASA. I think that was very well received in the working group. Tooling reminder, if you're getting into Anima at this point in time and don't know how we operate, if you want to bring documents in and want to have them edited more easily by other members of the team, use the GitHub that we have for a long time. And then we're done with the chair slides, and given how our time 10 minutes, okay, I'm still good in the time. Any further question on this slot? Are we fine? Let me check to that. Okay. All right. So let me swap over to the next slot, which is the ACP update. So let me see that I'm publishing the screen. Yes. And then let me just share the entire screen. I think that's easier. So hopefully, let's check again. Do you folks see my ACP update full screen? Hello?
Yes, we can see it.
Yes, I can.
Okay. Excellent. Thank you. All right, so we were at 28 after IETF 108. So the majority of the time was actually spent with the ISG final reviews for dash 29. I converted to XML v3, which is, I think, recommended for every document now to speed up RFC editor paths because they need XML v3. I also did it because I put Pascal, Michael, and Brian into contributors, and that only has formal XML tags in version 3. So 29 closed all the remaining discusses from the ISG, Roman, Ben, and Barry. It also closed all the comments from the ISG, so maybe some quick highlights that I felt might be, technically interesting. So there was a good 2 more pages of security considerations from the questions raised from the security reviewers. So core things that we, as the authors all have been taken for granted, but then couldn't find good references to point to either, such as, that IDEF ID and LDEF ID need to be protected from private key extraction through mechanisms like TPM or others, and that attacks against the software, of course, can impact the security of the ACP. So you want to have hardware with secure boot and software upgrade. The registrars and the EST protocol, of course, are one of the core attack vectors. So it's quite important to make sure that only the registrars have the this tag in the certificate that gives them the authorization to be registrar, so that not every device could be hacked to become a registrar. And then I think, the remainder of the security considerations are really the ones also applicable to EST, nothing new. Otherwise, the man-in-the-middle attacks, the ACP is fairly well protected against that. Discussed how the grasp discovery of EST could be a problem, but I think concluded it cannot be. So I think that's very useful to show that there has been a very thorough security analysis of the ACP security model. Ben brought up the point about the well-known port, the port numbers in dull grasp during discovery of neighbors. I refined that to explain how that's a possible attack vector. We were discussing this and didn't have these port numbers 5 years ago when we started, so they sneaked in later on because we were looking into DTLS. So that's still, something which people cannot fully agree that, well-known port numbers are a good way to avoid this problem. But obviously, once we would see that for DTLS, this would become a problem, we could go forward and ask for an ACP over DTLS well-known port number to avoid that problem. But given how right now we're focusing on IPsec, I think we shouldn't be worried about this. Yeah, formatting, CBOR, CDDL. Finally, I hope we've got all the extension points ready so that we're doing extensions to the ACP, both in the certificate and other places, that we're not going to run into issues, and also don't even need to necessarily do any updates and are fully backward compatible. Well, remember, starting out grasp by outsourcing the security into ACP. So I think we now got in the new section 6.1 a good summary of, I think the really good profile on how to use TLS for things like ACP. Obviously, this for the ACP should be good reference when others run into this very long process figuring out what exactly a minimum profile and requirement text might be. So and then there is a new section 10.9 for a possible future ASA to discover secure channel downgrade attacks, given how we explicitly want the flexibility of multiple protocols for the ACP. We obviously want to make sure that in case that one of them is the least secure one, that we discover when somebody man-in-the-middle does a downgrade attack there. So yeah, that was good time and work spent. Then basically when we're done, the thing went to Eric. And so dash 30, which is now in the RFC editor queue, was kind of the leftovers run. Yeah, one of the problems obviously is that I've been doing the final English check on that one. It's really stupid. I haven't found a good spelling checker that avoids to repeat 1,000 times non-issues raised, so that's why I was doing it just at the end. There are now 4 sections in a new Appendix B, which are marked for removal by the RFC editor, which is capturing the things that we either couldn't get agreement on or where there wasn't enough review to make them safe for the RFC. The first one is this very old negotiation via GRASP for the ACP secure channel mechanism. I had left it in the draft for feedback from ISG. Actually, Ben liked it, also suggested additional text, but still I felt not safe to move it into the RFC given how we couldn't finish the text and how the working group originally thought it was too much for this initial RFC. And then the other 3 were kind of smaller things. So one that we discussed very early on as well, kind of should the ACP address in the forwarding plane for a peer be verified? And there is good discussion about that, but I don't think we have given recently enough consideration for that. I think the answer is no. Then basically, I think a very interesting discussion about how would we use ACP with public CAs, well, guess what? If we had RFC 822 name as before -25, we could use them today. So this is somewhat of a painful topic. And then the hardening of the dull grasp from the prior slide. So yeah, we ended up with a normal process. So you have to know that change log and everything that didn't make it into the RFC is documented in the last draft to find these things. But at least for us in the working group, when we want to go back later on and pick up on additional things we want to do for ACP, that's where it is. Right, and that's pretty much it. So yeah, cluster C325 is unlocked. So kind of the end game of the dungeon. I think that's where the RFC editor sits behind that big door. And well, thank you very much, everybody involved, especially all the hard work also from the ISG in all the reviews. It took a very long time, but I think it was worth it from really the fact that there are a lot of security related things around the ACP. By now I know a lot more than even BRSKI itself, so that was definitely well spent. Okay. That's it. Any more questions about that?
No questions, but I just wanted to chime in to say a big thank you to us for getting this one over the line, and the amount of effort you've put in, and the working group, and also Eric's help as the shepherding AD for this. So I'd just like to thank everyone. I know this has been a tricky document.
So, right,
yeah.
Would the presenter, oh, sorry, go ahead.
Yeah, that's a shame. As the chair and also the document shepherd of this ACP document, thanks so much, Terry, for your hard work. We have been very long process for this document, and up to now, we can finally call the victory for our ANIMA stage 1, start from 2014. Yeah, this is the last document in our stage 1, and actually we can together release the 5 RFCs. One of them already be in the list for more than 1,000 days. Yeah, right. And by now, actually, we had our original autonomical network infrastructure components, 3 of them all published, complete, and that including the ACP and BRSKI and GRASP. We hope, in this second stage, we can see more autonomical service agent, which reuse those components as we hope. And then finally, we could get our autonomical network and the services, be used in the real world, and that makes the network management and the network maintenance much easier. Thanks all. Yeah.
All right. So, Michael, I think you're going to take this one. Do you want to just say next slide?
Next slide. So it says in August, we had a conversation coming out of the BRSKI async enroll and the CMP work about whether or not the BRSKI thing should be under EST or not. And after, I guess, a fair bit of back and forth, we decided that they should ideally, because the document was sitting in auth 48. So a change was prepared to discuss it. There's the difference, the diffs are in that email that's listed there. The couple of implementers were contacted, and they're all kind of, yeah, we can make this change. It's not so terrible. And particularly on the registrar side, it's easy to support both. So if you have your own, pledge code that you don't want to update immediately, then you could support the old names as well as the new names. But going forward, we would use the new names. Warren put it into a we had a working group last call, I think, on that, and then we had an IETF last call that concluded on September 14th. So that was version 44 updated, and that changed some IANIC stuff, and a conversation with Mark Nottingham occurred as the well-known reviewer, designated expert. So that went okay. Next slide, please. So what does this look like? There's a picture of 1,000 words of differences. Basically, it took some couple paragraphs here and there to change it through the thing. Next slide, please. Okay, so then what was that in mid-October, 3 or 4 weeks ago? Torlis noticed that we had a missing IANA action for the AN proxy and the AN join registrar, which was supposed to be allocated out of the GRASP registry. And so again, we did some similar thing, new document, the paragraph there at the bottom, you're scrolled a little bit up maybe. And there we go. So those two lines were added to allocate the thing. This went again, had an 80 approval, no IETF last call. It was a oops. Again, it was sitting in the RFC editor queue anyway, so it got updated and went in, and IANA has signed off on that. Next slide, please.
Yeah, and that was because I was going through the registry for the ACP at that point in time.
Yeah, so thank you. So I keep hoping for auth 48 any hour now. We appear to be at the top of the RFC editor queue. So I think it's any minute now there will be an auth 48 for that. So thank you again for all.
Yeah, so Brian was already mentioning some activity from RFC editor on GRASP.
So he's in auth 48 then. Okay.
No, not
wonderful.
auth 48 yet. There was some other indication that they're seemingly already working on something. Okay.
So I assume they're working on it.
Yeah.
Yeah, again, it's a dark dungeon down there behind the door, so we're not really sure what's going on. We're just looking at the status of the cluster.
So there's a Canadian restaurant that has a really delicious root beer called BRSKI. I was going to acquire some for the Vancouver meeting, but a quantity enough for everyone in the room, but it won't happen, right? Okay, next document then. You can't make it full screen, eh?
Well, with this PDF stuff, I could try.
It doesn't matter.
Where is it? Enter full screen.
Yeah. Turn off continuous scroll. Continuous scroll, and then it won't be so stupid. And you'll be able to page down.
I hope, yeah.
Okay. All right. Yeah. So constraint vouchers. So we've been working on this. This is Peter, Esco, Panos, a few other people that have come to the Thursday design team meetings. And so this document, if you haven't read it before, essentially replaces HTTP with COAP, replaces TLS mostly with DTLS, but also possibly with OS core, and basically makes it a much more constrained scenario. It uses Yang schema identifiers, which are still in the core working group. I believe they've just finally passed properly into the IESG, and I hope they'll pass through easily, but we'll see. That's probably the critical thing for this document. It's not yet obviously critical path because we're not done with it, but it would be very nice to have that document finished, because it was rather difficult to figure out how do we allocate numbers from a registry that isn't yet created. So in fact, the SID document now contains an allocation for us there. Next slide, please. So we've moved it to BRSKI, as was discussed in the previous document, the shorter versions of that, and we've updated some of the examples of how things work. One of the conversations is that in COAP, you can do a resource discovery. And now the question is, well, previously you could ask for est.star and get all the results back, including the enrollment things, if they were moved somewhere. Now you'd have to do two passes, one ask for EST or maybe CMP, and then one to ask for BRSKI. So that may take 2 round trips, or etc. So one of the conversations that we've had is that the well-known things are mandatory to implement. If you want to put it elsewhere as on the registrar, if you want to put it elsewhere as well, then you can do that. And this means that a client can, if it wishes, can skip the discovery process if it knows where the registrar is already. The discovery typically could be, for instance, multicasted to find out what registrars are out there. Next slide, please. We have asked the question, come back to why are we doing CMS sign CBOR? That was a request when we started this document to do this, and we don't seem to remember who or why wants that, and it seems really daft, but we're going to do this. So we were asking the working group what's going on. We have some clarifications around the use of proximity registrar public key info, and we have some interactions with questions about how it deals with a composite or asynchronous registrar. So we meet there's a design team meeting on Thursdays it's at 7:30 a.m. my time and sometime in the afternoon in Europe. And the invite is open to the mailing list, and please join us. Next slide.
Yeah, maybe send it out again. It's somewhere down in the mailing list, so reminder is always a good thing once a quarter.
Yeah, so I will send a mailing list, a summary of some of what this is discussed and some deeper things. So one of the things, the discussions we had is, as you know, we have actually, next slide, please. We have a pledge next. We can just guess and hit down. Next, we have a registrar and we have a massa, right? So we have those three things. Next slide. So we wind up with a connection between the pledge and the registrar next. And we may have a joint proxy in between there. Next slide. If you're making a presentation, by the way, and you want these icons, they are in the IoT Directorate GitHub as well. Next slide. So you can put a cozy sign CBOR, and we do this over COAP. So that's what this document is about, right? Mostly, okay. So that's well understood. That part is COAP. That part is cozy. Next slide, please. And so then we make a connection from the registrar to the massa. Next slide. And I proposed some years ago that we call this one the parboiled voucher request. Not everyone loved that term, but no one's proposed something better. And that this one would also be cozy sign CBOR, and in the prior signed voucher request would contain the light purple one that from the left, which was in format cozy sign CBOR. Next slide. And that would occur over HTTPS, not over COAP. And there's a couple of reasons for this. One is that it is observed that COAP does not, and UDP protocols do not get in and out of corporate environments that easily, is one point. And the second point is that there's not much experience out there in the general web service population of building and scaling COAP-based systems. Whereas scaling HTTPS systems is like, I'm not saying it's ubiquitous, but it's pretty hard not to bump into people who know a fair bit about doing that in pretty much any enterprise and space. Entire companies are based upon doing that. Next slide, please. So what you get back is a voucher, okay? And it's in the format that you asked for. I will say that my code assumed that the voucher format coming back should always be the same as the voucher format that was presented. But actually that's wrong. And it doesn't really matter in the core BRSKI document what you do, because we have only one choice. But so we putting some clarification in here that actually the answer is, well, HTTP has an accept header, and that's what you should be using to tell what kind of voucher format you want back. But also the MASA knows, because of its relationship with the pledge, what kind of voucher formats the pledge can accept. And so it should send one that the pledge can accept, but should also consider what the registrar is asking for, because the registrar would like to audit it. So the registrar can give a preference, but the MASA is going to return the one that the pledge can actually process. Next slide, please. So yeah, that's the same point. Next slide. So start again here. Let's think another way of this, right? One proposal was, next slide, please. We have this COSI signed CBOR as before. Next slide.
Can you just say click? That's faster.
Click. Click. Okay, so we make the connection, click. What if we put a CMS signed JSON here? So that's what the core document says, is you do CMS signed JSON. And there's no reason why we can't store the COSI click. Why we can't put the COSI signed CBOR in as the prior signed voucher request in a CMS signed JSON. Yes, you have to base 64 encode it, but you have to do that anyway for the anyway. And the interesting part about this is that this means that on the right hand side, the registrar essentially always sends out the things in the same request, and the MASA always processes things in the same request, regardless of whether it's a constrained or a non-constrained request. But of course, actually, both things still have to process COSI signed CBOR. So they're not really getting out of too many code paths, but maybe there are some code paths we discussed whether this would make sense. Next slide, click. And again, we do that over HTTPS. So that's even more kind of a third level of thought. Click. And we get a voucher back. Click. So in this case, so we have this interesting thing that you asked with CMS signed JSON, but you got COSI signed CBOR. Click. So this is the case that we think basically we thought we discussed that a fair bit, and we basically decided that previous case was dumb, that we didn't like it. In particular, it means that a MASA that only deals with constrained devices would have to speak non-constrained voucher request content, and it doesn't remove really any code paths from the registrar. So click. So we're sticking with this as the model, that you do it this way. Okay. Oh yeah, and we could do this over COAP, all right, as well as the possibility. And we said that's dumb, so we're not going to do that either. Click. Right. So there's the not doing that. Click. And not doing this. Click. So just a little bit of a kind of summary of these issues, all right, about what the different things are and how it does things. And the consensus that we had in the design team was that you will always sign your parboiled voucher request with the same format as you received. Okay, so all these other variations are not. That we will not use CoAP-S between the registrar and the MASA for the reasons that were stated there. I think that's the last slide. Click. Oh yeah. Okay. This is the last slide on that topic. So the conversation we had to do with, and I still have a long email to try to explain this in more detail and to get some text into it. The issue is that one of the ways to build a scalable registrar is to separate the southbound, the pledge interface box in the bottom there, from the MASA client interface. So you could scale the pledge interface appropriately for the number of devices that you expect to unroll at any one time, which I guess at certain times of could be 0, and other times maybe it's thousands, and you need to have a fair bit more capability there to do that. And that's kind of typical, web-based scaling things with, I don't know, containers and orchestration and other stuff like that there. And then the only real connection from the bottom, which talks to the devices, the pledges, and the thing at the top, which talks to the MASA, is the database. So in fact, you can build a system that's asynchronous. You put the voucher request into a database. Maybe you send a signal, or the database sends a signal to the MASA client, and it goes off and talks to the appropriate MASAs to get vouchers back. And when you do this kind of thing, one of the things you realize is that you probably don't want to share the private key across all of these devices. In fact, there's nothing that stops you from having a different certificate on each of those pledge interfaces. So you can actually spin things up. And given that they actually, in theory, can be self-signed certificates, and as long as they last long enough for the voucher to pin them, there's not actually you could actually destroy them as you destroyed the VM or something like that. You could even do something like that. It's not how I design it, but you could do that. But in that case, the question is, what exactly are you pinning? And the answer is, in the non-constrained case where we're using certificates, the answer is, well, you should pin the CA. And we have some text there that clarifies this. And ESCO has been very persistent in making this clarified. And we have some of that relatively well clarified in the BRSKI document as well. And that's pretty easy. But in the case where you're using a self-signed certificate at the bottom, then there's no CA to deal with this, or a raw public key in the very constrained case. Then what do you do exactly? And so that's what we're kind of trying to figure out. What do we put in there and trying to get that text correct? I think next slide. Right. So that was it. Yeah. So that's the outline of the problem, and we're trying to explain the answer. And one of the answers for the constrained case is that we pretty much have to send some additional pieces and just clarify when you can pin things and when you can't pin things. And unfortunately, this means that there are actually some sane cryptographic scenarios that you probably shouldn't do because it makes your life too complicated. And so you probably want to back off. And that's the goal, is to clarify some of that, both in this document, but also in the registrar operations document. So that's about it.
So this last consideration for scale out, that's not specific to the constrained voucher case, right? That could equally be of interest for any of the other, let's say, the standard BRSKI option, right?
Right. Well, so if you're using PKIC certificates and you have a local CA, and you're using you're generating entity certificates for go to the previous slide if you could actually, and you're you're generating certificates for the pledge interface, the BRSKI EST southward facing thing from your certificate authority, then as long as you pin the certificate authority, that makes the pledge happy, and you can do all the scaling in all the different ways you like. It's when you substitute a raw public key down there that you realize, oh wait, there's no relationship to a certificate authority there, so I can't do anything specific. And there's another conversation that we had yesterday a little bit in the ACME working group about what happens if you like to use a WebPKI Let's Encrypt certificate for that pledge interface. What happens to the pinning process and to the CMCRA bit? That's a different conversation that requires a longer thread to discuss.
All right, I think we're still in time. Thank you very much. Any more questions on this? Then let's move on.
Oh, there's some slides. There's some slides after the last slide about the constrained join proxy. If you just give me 1 more minute.
Okay.
Okay. That was in the same deck. Yeah, there you go. No, that's not my slide, is it? Draft relationships. Yes, it is. I'm sorry. Yes, there you go. So the constrained, yeah, so there's the constrained join proxy document. And this has been revised a few times by the design team. Next slide. Click. So BRSKI uses HTTP and TLS, essentially builds a circuit proxy. There is a way to do this statelessly with CoAP, which comes out of the 6-dish working group. But there is no way to do this statelessly with DTLS. You can build a circuit proxy creating state, but there's no way to do this in a stateless way with DTLS, and this document tries to do that. So next slide, please. So we document the stateful one. It's essentially a version of NAT circuit proxy, and a stateless one. And there's a little bit of tweaking of the text to explain it, but essentially it's waiting for a working group adoption. That was it.
Right. Have you seen? I'm trying to remember what the working group is, right? So there's a lot of, also these type of proxy things for Quick happening, and Quick is trying to get also into the datagram service. So are we, going to wake up in another year or so and having to do everything we're doing with DTLS with Quick?
Well, so the BRSKI circuit proxy, which is TCP based, it's not going to work with Quick. And so if you want to run Quick on that, then the answer is yes, we'll have to do something. I don't know what. And I guess I could go look at those documents and see if there's something there. Maybe part of the answer is don't bother with maybe it's stupid to do DTLS if you're going to do Quick anyway. But I don't know. I would appreciate some other feedback from people as to whether to deal with all of these different possibilities. Who really wants what versus maybe the answer is just if you can't use TCP for some reason, can you really use Quick? I don't know the answer to that question. I would tend to think that if you're in that constrained space, that you are probably more interested in using ad hoc and OS core than you are in using Quick.
Yeah. Well, I mean, yeah, I think that's just always keep it in the back of your mind, right? That there's a lot of, effort wasted, not wasted, invested into the DTLS solution. So let's make sure that we're kind of continuing to.
On the registrar to master side of things, if you can get Quick through the enterprise, then you can use it as you like. It's just HTTP, whatever, 3 or whatever we're calling it, right? We don't care.
Okay. So I think Stefan wanted to take these slides.
Yes. Okay. So I would like to give an update on the BRSKI-AE asynchronous enrollment draft. We haven't submitted an updated draft because we are still working on one of the use cases to get more meat into the use case and get a better description of the single items that we will talk about in a minute. Click. So just to recall, what is the problem statement for BRSKI-AE? We have use cases where we see that there is no connection to a backend infrastructure. So there is a mechanism needed that we need to bind the certificate signing request directly to the identity of the pledge. We use that we address that in use case 1 by basically using signed wrapped objects, which are used for the certification requests in the same way as the voucher request. That poses some requirements to the enrollment protocol. And in use case 1, we are mainly focusing, or we are mainly pointing to enrollment protocols that support those signature wrapped objects for certification requests, which would be, as stated in the draft, EST with full CMC or also the lightweight CMP version. Click. So that there was no change to the description yet for use case 1. Use case 2 introduces a push model. So we call it push model because in the original BRSKI draft, we consider that as pull model because the pledge pulls essentially all necessary information like the voucher and the certificate from the infrastructure via the domain registrar. In use case 2, in the push model, we reverse that role because in industrial environments, typically the pledge side would be the server side. So that means we need to provide that reverse role description. So the draft, again, uses signature wrapped objects to basically have a secure exchange between the pledge and the domain registrar. So if you jump to the next slide, then we can see the architecture for that. So on the right-hand side, you see that between the pledge collier and the domain registrar, there is a new component called pledge agent that basically works as a proxy between the pledge and the join proxy. And so the use case 2 is currently what we are focusing on, also in the discussion of the in the design team, which Michael mentioned. So the protocol approach at first we thought to be very close to BRSKI. So we at the time of discussion now we are at the stage where we say between the pledge agent and the pledge collier we use a similar approach as in BRSKI. That means HTTP and TLS between those components. What we are currently discussing is the trust relationship between the pledge agent and the pledge, and also between the pledge agent and the domain registrar. So we had some discussion of how to use TLS between the pledge agent and the pledge because there is no prior trust relation for them. So we thought about using a PSK-based cipher suite in TLS, which can be used to at least vouch for proximity between the pledge agent and the pledge. So the intention is to have as less trust assumptions on the pledge agent for that, because he actually works as a proxy between the pledge and the registrar. So the security as such depends mostly on the signature wrapping that is happening between the objects exchanged between the pledge and the domain registrar. So that is currently in discussion. So a further point is the endpoint definition for the pledge itself, because the pledge, as said, acts as a server. So we need to have endpoints defined on the pledge side to be able to contact the pledge and to request certain actions. So for that, we also relied on the currently defined approach in BRSKI. Period. Next discussion is related to the object format for the exchange of the signature wrapped objects, and that goes back to the discussion that Michael was just had with the previous draft. So currently we think about something like JWT signed JSON as object exchange between the pledge agent, the pledge, and the domain registrar. Okay, so because I just read it, the comment from ESCO, so the intention also to use a PSK-based mode between the pledge agent and the pledge itself was also to not rely on or to not bind the exchanges to TLS, because if there is some other means, some other transport means between the pledge agent and the pledge that doesn't feature TLS or HTTP, like NFC or Bluetooth, then we may not be able to rely on the transport security as defined then if it is bound to TLS. So that was the reason to just take a PSK for vouching for proximity. So I have some more detailed slides on the backup. So probably need to click twice. Right. So that was the discussion that we have in the design team. So more or less repeating some of the things I already said. So the potential use of a QR code or something similar to vouch for the proximity between the pledge and the pledge agent is currently being discussed. That relates to the TLS and TLS cipher suites to be used. We discussed also to use something like the subcerts that is currently in discussion in the TLS working group. But it's, yeah, because of the possibility to use Bluetooth or NFC or other protocols between the pledge agent and the pledge, we decided that this is not a good fit because that has a high dependency on TLS, obviously. And regarding the trust relation between the pledge agent itself and the registrar, the draft currently mentions that there are two options. So the pledge agent may feature an LDAP that can be used for client-side authentication in TLS. Then if this is the case, we have to address that the pledge agent authenticates towards the registrar instead of the pledge authentication within TLS, because the pledge agent then would utilize that communication to forward the voucher request and also the certificate signing request or the enrollment request over to the domain registrar. Right. So can't see what's on the slide down there. So we have some open discussion regarding the potential attacks. So regarding the security considerations, and from the discussion we had during the last design team meeting, we figured out that from a security perspective, there is a denial of service attack possibility on the pledge if the pledge has open endpoints and can be triggered. But except that, we haven't seen different attack vectors than addressed by BRSKI itself. So that is the state for that. If you jump to the next slide. Yeah, those I mentioned that we currently discuss about different endpoints on the pledge side. So we currently define 4 different endpoints. One is to trigger a voucher request. So that would mean that the pledge agent triggers the pledge to create the voucher request. Then the same would be done with the enrollment request, resulting in a certificate signing request, PKCS10, which is being forwarded then to the registrar. As soon as the pledge agent talked to the registrar and the registrar did the backend communication with the master and the domain CA, and he gets back the information about the voucher response and the enroll response, he gets back to the pledge and provides those information to the appropriate endpoint. So that would be the voucher response that provides the voucher status as answer, and the enrollment response would return the enrollment status that can be then further processed by the domain registrar. So as said, we have some clarifications regarding the encodings of the different objects that are going back and forth. So if we use CMS signed JSON or JWS signed JSON, but that is open currently. Okay, so then on the next slide, there is just a small summary of changes in the draft. I won't go into detail to that because of the matter of time. There are just some updates to different sections in the document to better explain and motivate the use case 2 with a push model. And the next slide shows some discussion and open issues from the last meeting that we discussed there. So discovery of the enrollment options on the registrar, that was addressed by Michael. Thanks for that in the BRSKI main document. So the change from EST to BRSKI, which allows to use all the other enrollment protocols on the registrar side. Then we have still the ongoing discussion about the trust relation and the use cases, use case 2 in the design team. We had some discussion about the necessity of providing the proximity registrar certificate for the pledge to include that in the voucher request. I think that discussion is finished because from my understanding, we see that there is a necessity that the pledge agent basically provides a proximity register certificate to the pledge agent to be included in the voucher request. That enables the registrar at the end, because he doesn't have a direct relationship to the pledge, that the registrar can verify that he's indeed the registrar or the target registrar for that voucher request processing. Yeah, different transport options. That is something which is still open. The current draft, as said, assumes to use HTTP and also to use TLS. Next slide. So next step would be the further refinement of the push approach that relates to the use case 2. Also according to the discussions that we had in the design team, addressing certain open issues. And then the outcome will be circulated on the mailing list for further discussion and would be used to update the draft to be ready for the, I would submit that then probably in December or beginning of January.
Excellent, thank you very much. Any questions on that, on the microphone? Okay, nobody, sorry. Nope, okay, let's go on. Files, second. Sorry, what? I think I'm confused here. What was the? I have the last slide deck. The
cloud.
Right, the cloud thing. So where is the cloud deck? Don't think. Oh yeah, this. Right, there was no cloud in the name. That got me confused.
I'm sorry.
Yeah. Go ahead.
So Owen Friel, Rifat, and I spent a bunch of time in August and September on this document. Next slide, please. This is the change in the table of contents. You can see it's much expanded, and I would say pretty much complete at this point. Feature complete, probably has bugs. Next slide, click. So we reworked the terminology, which is on the next slide. We clarified the 2 use cases and eliminated 1 use case, and whatever the third point was, I missed. This is the terminology about what we're dealing with. So the local domain is the place where you're physically from, and it may be different than the pledge owner's domain. So you may, in fact, be bringing up a device or a pledge. And typically, in this case, the example we talk about is a SIP phone in a place other than where it is. So the example is you sent a SIP phone home, or in fact, maybe shipped it to an employee at their home because they're working at home. The owner domain is where the pledge needs to connect to, and the cloud registrar is a default URL that is well known to the pledge due to it being built in during manufacturing. There's a registrar that the owner has, and in some cases, we're saying that the registrar is an EST only registrar, not a BRSKI registrar. Next slide. So the 2 major cases are basically distinguished as to where there's a redirect and what form the redirect is. In the owner registrar discovery, what happens is that the pledge, which finds no grasp announcements in its lonely home, reaches out to essentially the cloud RA, and it sends a voucher request to it. And the cloud RA, having knowledge of where this device is supposed to be deployed based upon the contents of the voucher request and the IDEF ID that authenticated it, sends back a 307 location update, and basically redirects the pledge to try again with the owner registrar. So in this case, the scenario is the phone has been taken home, you plug it in, to the wire because we can't do onboarding on Wi-Fi without some local help. So we assume we plug it in, and then it discovers, oh, you're supposed to be connected to this hosted PBX system, and it reaches out to that system using the same provisional TLS and does its onboarding, continues on. So next slide, please. And the other situation is one where the enterprise is perhaps a little bit more advanced, or in some cases, maybe they are a little bit more behind, having implemented something maybe a decade ago, and they have an EST system. It doesn't speak BRSKI, however, is the problem. But it could onboard a device if only the device knew to talk to it. And so that in this case, what happens is that the cloud RA answers the voucher request with a voucher, but it doesn't pin itself to the device. Rather, it pins this EST server and tells it where to find the EST server. And there's also in the text some explanation of where it might find its configuration data. But the important part is the redirect is contained within the voucher, and it happens after the voucher is issued. And I think that's the last slide, but next slide. Yeah, questions, Dot.
Okay.
I think we're right on the dot.
Yep. 90 seconds over. So yeah, please, repeat the question on the mailing list, and then we'll go from there. And yep, that's the end of the time. That's the end of the agenda. Thank you very much. And I guess see you all virtual in wherever the next cyberspace is that we're meeting in March. Bye now.
Bye. Thanks all.